Most teams think of GitHub as just a place to store code. But what if it could be more? What if it could be your package registry, container registry, and distribution platform, all in one? I'm Michael Michel, and in this session we'll cover publishing and managing packages using GitHub Packages. We will focus on how GitHub Packages enable you to store and distribute everything from NPM and NuGet packages to Maven artifacts and Docker images directly along your source code. In this session, we'll look at how to unify your deployment workflows so you're not relying on separate systems for code, CI/CD, and package management. We'll look at how we can automate publishing using GitHub Actions and how you securely manage and consume packages across your organization using same identity and permission model. So let's get started. So let's look at how we're going to build an automated pipeline using GitHub Actions. This GitHub action is going to take your code and turn it into a published package or a container registry image. The flow is simple, but really powerful. Whenever code is updated or a release is created, a workflow is going to be triggered. The workflow performs three key steps. First, it builds the artifact, whether that's an NPM package, a NuGet package, or a Docker image. Then it authenticates securely using a token. This is typically done using the built-in GitHub token, so you don't need to manage credentials manually. Finally, it will tag and publish the artifact. It will publish it to GitHub Packages or the GitHub Container Registry. It's your choice. The result is a fully automated pipeline where code changes lead directly to published artifacts. No manual steps. So this is key capabilities for modern DevOps operations. Modern DevOps workflows depends on it. It enables teams to consistently build, version, and share their software. We actually look at the automated package. We look at it and how can we create one using GitHub Action. The key here is that instead of manually building, packaging, and uploading artifacts, we're going to have a workflow. This workflow handles everything for us. It typically starts by building and testing the code and making sure everything is working, then automatically publish the package. What's powerful about it is that the entire process is event-driven. So when the moment the release happens, the workflow runs without any manual intervention. In a real-world scenario, this means a developer can push code, create a release, and GitHub Action will take care of packaging, publishing on GitHub Packages. This is consistent and repeatable operation. This only saves you time, but also saves you errors. It reduces errors and ensures everything is packaged and built according with the same process. So if you have a certain set of standards, that's what you're going to be following. The key takeaway here is that GitHub Action turns publishing into automated pipeline. No manual step, no inconsistency, just a reliable way to build, test, and distribute your package. Let's work through a simplified version. Let's work through an example. The workflow here is triggered whenever a new release is created. This ensures publish is tied directly to version release. The workflow is split into two jobs. The first job is the build job. The job installs dependencies using npm CI and then runs tests using npm test. The purpose here is validation. We want to make sure the code is working before publishing everything. The second job is the publishing job. This job only runs if the build job is successful. It setups the environment again. It connects to the GitHub package registry and then runs npm publishing. Authentication is handled automatically. We use the built-in GitHub token. This is important. This means that you don't need to manually manage credentials. The key takeaway here is you validate, then publish. So only tested and verified code is released as a package. We focused on publishing code. We focused on publishing packages like npm or NuGet, but GitHub Packages also support container image. That is done through GitHub Container Registry. This registry allows you to store, manage, and distribute Docker images directly within GitHub. One key advantage is flexibility. Unlike traditional registries that tie images to specific repositories, GitHub Container allow you to organize images at the user or the organizational level. So your registry can be organized on both of those levels. You can also get fine-grained access control. That means you can define exactly who can push, pull, or manage each one of your images. Just like code packages, you can choose whether images are public or private. In practice, the registry is commonly used in your CI/CD pipelines with GitHub Actions. So in the development environment, you'll be able to develop in local machines or cloud deployments. It's not only for code. We keep repeating that GitHub is not only for code. It's a full system. You can use container registries, you can create central hubs, so you will be able to build and manage your artifacts. Once you build the Docker image, the next step is to publish it to GitHub registry. This process happens in 3 main steps. First of all, you log into the container registry using a token. Maybe you're going to use a personal access token, or you're going to use the GitHub token. We use the GitHub token mainly when working in GitHub Actions. Remember that. Then we tag the image. This really assigns a name and a version, an ownership to the image that you can be stored and referenced correctly in the registry. That's how we will be able to pull it later using that tag. Third, we push the image. This will upload the image into the GitHub Container Registry where it can be accessed by your team. Your CI/CD pipeline or the deployment environment will also have access to it. In practice, we rarely run these commands manually. Instead, the entire process is automated using GitHub Action Workflow. Now the images are consistently built and published every time changes happen. So far, we've looked at publishing container images, but GitHub Packages also support traditional code packages across multiple ecosystems. This includes NPM for Node, NuGet for .NET, Maven and Gradle for Java, and Ruby Gems for Ruby. One of the key advantages is that you don't need to learn a new system. You continue using the existing package manager, but instead of publishing to an external registry, you publish directly to GitHub Packages. To authenticate with GitHub Packages, you need 3 things. Your GitHub user account, or your GitHub username, your personal access token, and the registry endpoint for your ecosystem. This setup allows your package manager to securely connect to GitHub Packages and treat it like any other package registry. The key takeaway here is that GitHub Package integrates seamlessly into your existing development workflow without requiring any new tool or new skills. To interact with GitHub Packages, you need to authenticate securely, and that's where PAT, or Personal Access Token, come in. PAT is essentially a secure credentials that acts like a password when your tools connect to GitHub Packages. You use it for actions like installing packages, publishing new versions, or managing existing packages. And instead of using your actual account password, you generate this token with specific permission, such as read access or write to the package. This is important for security because it allows you to limit exactly what can be done with that token. So you build that token for a very specific job. There are a few best practices to follow. Always treat tokens like sensitive credentials. They are credentials, so never store them in your code or share them publicly. Use the principle of least privilege by granting only the permission that is required. So read when you need to read, write when you need to write. And rotate tokens. Rotating them regularly reduce the risk if they are ever exposed. In the main workflow, especially with GitHub Action, you can use built-in GitHub token instead of managing a PAT manually. It's the recommended process as well. Before you can install or publish packages, your package manager needs to authenticate with GitHub Packages. Regardless of the ecosystem they're using, whether it's NPM, NuGet, Maven, or Ruby Gem, the process follows the same pattern. Your package manager connects to GitHub Packages as a registry. The registry URL includes the package type, like NPM, NuGet, along with your GitHub username and organization. Authentication is then done using GitHub username and PAT. This token will replace the password and allows you secure access to your package. Each ecosystem will have a slightly different command. You can read more on your Learn module. The important takeaway here is that once you understand how authentication works for one package manager, the same concept applies across all others. So GitHub Packages are easily adopted across different languages and different environments. Once you authenticate your package manager will be able to install the packages in a very straightforward method. You simply use the same tool, you're already familiar with, like npm, NuGet, or Maven. One of the most helpful features is that every package page in GitHub shows you exactly the install command you use for your specific environment. That means you don't need to remember registry URLs or command syntax. So GitHub Packages create the seamless environment for developers' workflows where you will be able to consume dependencies just like any other packages in your registry. You can see this example on my screen. GitHub Packages doesn't just store your artifacts. That means it is a tool for you to manage the entire lifecycle of the package. One of the most important ways for you to do this is through automation in GitHub Action. You can automate tasks like publishing new versions, updating packages, or cleaning up old versions. You can also integrate with GitHub APIs. This includes REST and GraphQL. This will allow you to programmatically manage packages, build dashboards, or enforce policies across your organization. Another important capability is event-driven automation using webhooks. For example, when a new package version is published, you could automatically trigger the notification, update documentation, or kick off downstream process. A real-world example here is automatically cleaning up old package versions. This way we reduce storage and keep our registry optimized and reduce cost. The key takeaway is that GitHub Packages support the full lifecycle. So from publishing to automation to cleaning up, so you can scale your package usage efficiently. Let's wrap up with a few key takeaways from this session. First, GitHub Packages provides a centralized place to store both code packages and container images directly with your source code. Second, GitHub Actions enable you to fully automate the build and publishing process, turning code changes into publishing artifact with minimum efforts. Third, authentication is handled securely with PAT, personal access tokens, or the built-in GitHub token, allowing your workflow and tools to interact with GitHub package safely. GitHub Packages integrate seamlessly with existing developer tool, whether you're using npm, NuGet, Maven, and Docker. So teams don't need to adopt new systems. And finally, GitHub provides built-in capabilities to manage the life cycle of your packages, from publishing to automation to cleanup. If you keep these principles in mind, you can build scalable, secure, and automated pipelines, managing your applications and artifact in GitHub easily. In this knowledge check, we'll validate your understanding of when you use and not use GitHub Packages, and how to authenticate and pull images using personal access tokens. Review each scenario carefully and select the best answer. In which scenario should you not use GitHub Packages? When I want to share code between methods of my application? When I want to share container images among developers of your team? When I want to publish a small code library as an open source project? When I want to share code between methods of my application? When pulling an image to your local environment, which credentials are needed? Your GitHub username and personal access token, the name of the organization and an API key, the name of the package and a package key, your GitHub username and the personal access token. How can you authenticate to GitHub Packages from your local development environment? With an API key? With my GitHub credentials, username and password? With a personal access token? With a personal access token. In this session, you'll learn how to integrate GitHub Packages into your development workflow, deciding when to use package registry, setting up a CI pipeline with GitHub Actions, and building and publishing packages and managing authentication and installation of your published artifacts. We've reached the end of GH-100 GitHub Administration course. By now, you should have a clear understanding of how to manage GitHub at scale, from identity and authentication to permissions and governance, so you can enable teams to collaborate effectively while maintaining strong security controls. The real value of GitHub administration is finding that balance between speed and control. I encourage you to remain curious and continue exploring new capabilities. That's how you'll keep staying relevant. There are many ways to continue your learning journey. I invite you to search for the next favorite topic on Microsoft Learn at aka.ms/learn.